Lesson 2 from first to fourth generation. Introduction. Imagine a big central pot of water getting heated up. This hot water is then sent through a network of pipes that run underground.
These pipes are like the branches of a tree, spreading heat to every home and building connected to the system. In technical terms, a district heating system uses a network of pipes to utilize local fuel or heat resources that would otherwise be wasted in order to meet the heating needs of local customers. Traditional excess heat resources are combined heat and power (CHP) plants, waste-to-energy (WT) plants, and industrial processes.
The roots of traditional district heating systems. District heating and cooling have evolved from various projects over time, with the centralization of heat generation being a key factor. The oldest operating district heating system is in Chaudes, France, using geothermal heat since the 14th century. Early documents even show people not paying their heating fees back in 1334. In the 1800s, Birdsell-Hulley pioneered successful commercial district heating, starting steam systems in Lockport and Denver in the USA. Denver's system, established in 1880, remains the world's oldest commercial district heating setup, now operated by Xcel Energy. New York's Manhattan steam system, operational since 1882, is still part of Consolidated Edison. While district heating isn't widespread in the USA, it's often found on campuses and in certain city areas. In Europe, the idea of district heating emerged from various projects influenced by early US systems. Germany led the way in the late 19th century with smaller applications. The first commercial district heating system started in Hamburg, Germany in the 1920s. These were followed by Copenhagen, Utrecht, Paris, Zurich, Stockholm, and Helsinki. Reykjavik, Iceland adopted geothermal district heating in 1930. These early projects laid the groundwork for today's district heating systems across Europe. In many cities around the world like Moscow, St. Petersburg, Beijing, New York, and many more, there are large-scale district heating systems. In fact, there are around 80,000 of these systems globally. The European Union has over 5,000 systems, with significant shares in Denmark, Sweden, and others. Iceland leads with geothermal district heating, while Russia and former Soviet countries also have several systems since they were promoted before 1990. District heating generations. Academic literature commonly presents 4 generations of district heating. There has been debate in recent years over the definition of the 5th generation, since some researchers claim that it has the characteristics necessary to be considered a generation, while others disagree. According to the International Energy Agency (IEA), generations have always been divided based on the technology used as the best available technology. In this lesson, we discuss the first 3 generations, which shaped the district heating landscape until 2020. The first generation, 1G, of district heating was characterized by the use of high-temperature steam, delivered through concrete ducts. This was different from early hot water systems in ancient cities and early steam systems for electricity. Steam was chosen due to its availability from power plants and ability to meet the needs of large users. These systems operated at around 200 degrees Celsius, which posed challenges. Corrosion of pipes and energy loss were issues due to the high temperature. First-generation systems still exist in Paris and Manhattan. These systems were used until around 1930, primarily serving small industries, hospitals, and large buildings. Steam vapor being vented through a typical Con Edison orange and white chimney in the financial district in Manhattan, New York. Since steam vapor is hot, the chimneys around manholes are there to protect people from getting burned. Cones also maintain visibility for drivers by elevating steam vapor above street level. The vapor is caused by water falling on a steam pipe, or a manhole cover, or due to a steam leak. The second generation, 2G, of district heating emerged in the 1930s and brought significant improvements. These systems transported superheated water at high temperatures, greater than 100 degrees Celsius, and pressures, operating in a 2-pipe closed-loop system. This allowed for better heat reuse and distribution, improved hydraulic pumps, Piping and insulation led to higher efficiency and longer transport distances. European cities, including Berlin and Bucharest, adopted these systems for primary heating, not just densely populated areas. In the 2G system, pressurized superheated water replaced steam for heat transport. By converting waste heat from power plants into combined heat and power (CHP) plants, fossil fuel consumption is reduced by 50%. Compared to separate heat and power production, safety, efficiency, and the ability to use diverse heat sources were the main drivers of this generation's development. The third generation, 3G, of district heating is the most popular version of these systems. It gained popularity in the 1970s and 80s due to rising oil prices and the need for more efficient and cost-effective energy solutions. Unlike the previous generations, 3G district heating uses high-pressure water, similar to 2G, but at temperatures below 100 degrees Celsius. In 3G district heating, the transmission and distribution network is more compact and cost-effective. Thinner pipes with better thermal insulation are used, and advanced plate heat exchangers replace the older shell and tube designs. This not only reduces costs but also makes maintenance easier. These changes allowed for the development of district heating in countries that were hesitant before. Examples of 3G district heating include projects like the Athletes' Village in Glasgow, which provided heat for sports facilities and homes during the 2014 Commonwealth Games. This generation introduced heat interface units that give individual users more control over their heating.